Okay, this is the first lesson of Unit 3, graphing quadratics from standard form. So in the last unit that we just finished up, we talked about factoring quadratics, and we barely touched on the relationship between the solutions and the x-intercepts. In this unit here, we're going to get a little more in depth on about graphing the quadratics. And today we're going to focus on graphing from standard form. So if you remember, standard form is when we have the terms arranged in order from the greatest exponent. So here we have x squared, x the first, and then we'd have the constant. Okay, so we're gonna talk about how to graph a quadratic that is in this form here today. Um, the graph of a quadratic is called a parabola, and we touched on this a little bit already in the last unit, but the graph is going to be a U-shaped graph that either opens up or opens down, depending on the value of a. And as we look at these examples here, it says how can you tell it's a quadratic by looking at the equation. So if it's a quadratic, it's going to be degree 2. So the first equation, x squared, second equation, x squared, third equation, x squared. The fourth equation, okay, so this is in factored form. So if we were to multiply this out, we would end up with that equation there, which is in standard form. So this equation here in factored form and this equation here in standard form, those two represent the same graph, okay? But we're going to focus on graphing from this form here today. All right, so to start with, let's start with just the basic function f of x equals x squared. We have a table here, and with this table, it gives us the x values that we're going to plug in for x. So the first one, if I plug -3 in for x, so it would be -3 squared. So -3 times -3 would be a +9. If I plug in -2, -2 squared, so -2 times -2 would be a +4. -1 squared, so -1 times -1 would be a +1. If I plug in 0, 0 times 0 is 0. If I plug in 1, 1 squared would be 1, 2 squared would be 4, and 3 squared would be 9. Okay, so with these ordered pairs, let's plot these points over here. So we have -3, 9. So -3, 9 would be right here. -2, +4 is right here. -1, 1 is right here. 0, 0. +1, +1. +2, +4. And +3, +9. Okay, and if you notice, these points kind of mirror each other, and that's because the graph is symmetrical. The left side of the graph is the same as the right side. And this line right here, right down the middle, this would be the axis of symmetry. And our graph would look like this. Okay, with this point here, this point would be the vertex of the graph. Okay, what is the rate of increase for the parabola? So with when we get to graphing a parabola here in a second, we're going to talk about the rate of increase. And the rate of increase, if you look here from the vertex, so starting at the vertex, to get to that first point, it goes up 1/1. Then from, here, let me use a different color here. So here's the vertex. From the vertex, we go up 1 over 1. From this next point, or from the point that we just landed on here, you see that it goes up 3 over 1. And then from this point, it would then go up 5, oops, up 5 and over 1. Okay, so we went up 1 over 1, up 3 over 1, up 5 over 1. And if you were to guess, you would probably guess right. The next time that we go up, we would go up 7 and then over 1. Okay, and it's the same thing on each side of the graph. On the left-hand side of the graph, we go up 1 over 1, up 3 over 1, up 5 over 1, and here's our parabola. Okay. All right, and then here it says, what if the vertex is not at 0, 0? Okay, graph the parabola. Okay, so in this first example, the vertex is at positive 2, negative 4. So here's 2, negative 4. And it says A is 1. Okay, so anytime that A is 1, then our rate of increase is going to be 1, 3, 5, 7, 9. It's going to be consecutive odd numbers. So from this point right here, we would go from this vertex, we would go up 1 over 1, and we do the same thing on each side of the vertex. Then from the point that we just located, we would then go up 3 and over 1, and we do the same thing on each side of the vertex, so up 3 over 1. From the point we just found, we would now go up 1, 2, 3, 4, 5 over 1, and we do the same thing on each side. And then if we were to continue here, we would then go up 7 and over 1. Okay, and here's our parabola. Okay, the axis of symmetry. So the axis of symmetry would be the line that goes right down the middle of the graph. So the axis of symmetry here would be x equals 2. Okay, that's this line right down the middle of the parabola. Okay, in the next example, we have a vertex at negative 3, positive 9. So negative 3, positive 9. So here's our vertex. And this time, A is a negative 1. So to find the rate of increase, whatever A is, we multiply that by our normal rate of 1, 3, 5, 7, and 9. So since A is a negative 1, if I multiply negative 1 by 1, 3, 5, 7, and 9, I get negative 1, negative 3, negative 5, negative 7, negative 9. So instead of going up, since A, in this case, since A is negative, we're going to go down. So from the vertex, we would go down 1 over 1 on both sides of the vertex. Then we would go down 3 over 1 on each side. And then from the point we just found, we would go down 1, 2, 3, 4, 5 over 1. Do that again on each side. And if we were to keep going, we would then go down 7 and over 1. Okay, so here's our parabola. It opens down because A is negative. Then the axis of symmetry. Axis of symmetry is right here, right down the middle. So the axis of symmetry would be x equals negative 3. Okay, so now this is kind of the main part of today's lesson. So how do you find the vertex and graph a function when it is in standard form? So we have the function f of x equals x squared minus 6x plus 8. And we're going to start by finding the axis of symmetry, which is also the x value of the vertex. And we do that by using this little formula right here. So x equals the opposite of b divided by 2a. All right, so the a and the b, what that represents, or where that comes from, is when we have a function in standard form, the number in front of x squared is a, the number in front of x is b, and the constant is c. So with this function here, x squared minus 6x plus 8, a would be the number in front of x squared, which is 1. B would be the number in front of x, which is negative 6. And if we needed to know it, c would be 8. Okay, so there's a, b, and c, values of a, b, and c. So to find the vertex, this is what we do. We start by using this formula, so opposite of b over 2a, and this is going to tell us the x value of the vertex. So opposite of b, b is a negative 6, so the opposite of negative 6 would be a positive 6. And then 2 times a would be 2 times 1, which is 2. 6 divided by 2 is 3. Okay, so the x coordinate of the vertex, x coordinate of the vertex is 3. And now to find the y coordinate of the vertex, we're going to plug 3 in for x in our equation. So let me just scroll down here a little bit. So we've got f of x, or y, equals x squared minus 6x plus 8. Okay, and to find the value of y, we're going to plug 3 in for x. So y is going to equal 3 squared minus 6 times 3 plus 8. So 3 squared is 9, negative 6 times 3 is negative 18, and then plus 8. So 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. Okay, so negative 1 is the y value of our vertex. So the vertex is at positive 3, negative 1. So let's go up here. So positive 3, negative 1. Okay, there's our vertex. Now we said that the value of a is 1. So if a is 1, then the rate of increase, so the rate of increase is 1, 3, 5, 7, okay, consecutive odd numbers. And if a is 1, then that rate doesn't change. If a is something other than 1, then we would multiply a by 1, 3, 5, 7 to find the adjusted rate of increase. So our rate of increase is 1, 3, 5, 7. It's a positive 1, so it's opening up. So from our vertex, we're going to go up 1 over 1 on each side of the vertex. Then from the point that we just found, we're going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1. Then we would go up 1, 2, 3, 4, 5 over 1, up 5 over 1, and here's our graph. Okay. Again, we did that by going up 1 over 1, up 3 over 1, up 5 over 1. Okay, we did the same thing on each side of the vertex to find these points here so that we could sketch our graph. Okay, now the vertex is either a max or a min. So if it's a max, it's the highest point. If it's a min, it's the lowest point. Well, the vertex, so this point right here, it is the lowest point on the graph in this one. So this is a min, so minimum. The y-intercept would be where the graph crosses the y-axis. And so the y-intercept is right here. That's at 1, 2, 3, 4, 5, 6, 7, 8. So the y-intercept is 0, 8. It doesn't ask us for them, but if we wanted to know the x-intercepts would be these 2 points right here. So the x-intercepts would be at 2, 0, and made kind of a mess of this, but it'd be 2, 0 and 4, 0. Okay, then it asks us for the domain. So the domain is the x values. So if we look at the graph and what it's going to do on the x-axis, the graph is going to go infinitely. So it's going to end up growing infinitely both left and right. Okay. So if it goes infinitely left, infinitely right, then the domain would be all real numbers. And the range, which is the y values, the range is how far the graph is going up or down. And we want to start smallest and go from smallest to biggest. So the graph starts right here. So it starts at -1, and from -1 it's going to go up infinitely. So our range would be -1 to positive infinity. Okay, we have a bracket here instead of parentheses because -1 is included. All right, let's try it again. So we have f of x equals x squared plus 8x plus 10. So the first thing we're going to do is find the x, or the axis of symmetry, or the x coordinate of the vertex. So that's opposite of b divided by 2a. So a, in this problem, a is 1, b is 8. So opposite of b would be -8. And then 2 times a would be 2 times 1, which is 2. So x is -4. So our vertex, the x coordinate, is -4. And now we're going to find y, and we find y by plugging -4 into the equation. So we would have -4 squared plus 8 times -4 plus 10. So -4 squared is 16. 8 times -4 would be -32, and then plus 10. So 16 minus 32 is -16. -16 plus 10 would be -6. So y equals -6. So our vertex is at -4, -6. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay, so here's -4, -6. Okay, then the rate of increase. So again, this problem, a is 1. So since a is 1, then we have a normal rate of increase, which is 1, 3, 5, 7, etc. So from the vertex, we're going to go up 1 over 1. Then from the point that we just located, we're going to go up 3 over 1. Then from that point, we're going to go up 1, 2, 3, 4, 5 over 1. We're doing the same thing on each side. Draw your parabola. Okay, then let's answer these questions. So first of all, is the vertex. So the vertex, which is this point right here, is the vertex the highest point on the graph or the lowest point on the graph? Okay, and this one, it's the lowest, so it would be a minimum. The y-intercept, okay, so we didn't actually go far enough in our graph to find the y-intercept here. So we went up 1 over 1, up 3 over 1, up 5 over 1. So to see where it crosses the y-axis, I need to go up 1, 2, 3, 4, 5, 6, 7 over 1. So it would actually cross right here, which is the point 0, 10. And one important thing I want you to recognize here is that the y-intercept is always going to correspond to the value of c. So whatever c is, that's going to tell us what the y-intercept is. Okay, so c is 10, so the y-intercept is 10. Then our domain, okay, so again, the domain is the x values. So domain is how far the graph is going left and right. So the graph is going to go infinitely left and right. So the domain would be all real numbers. The range is how far the graph is going up and down. So the graph starts here at 2, 3, 4, 5, 6. Okay, so we're at -6. And from -6, it's going to go up infinitely. So the range is -6 to positive infinity. All right, let's try the next one. So we have g of x equals 2x squared plus 4x minus 6. Okay, so this time a is 2, b is 4, and c is -6. So if c is -6, then that tells us that we know the graph is going to cross the y-axis at -6. So this point right here, this is going to be the y-intercept at -6. Okay, and that's based on this right here. This is the y-intercept. Okay, so let's start by finding the vertex. So we're going to find x. So opposite of b divided by 2a. So opposite of b would be -4. And then divided by 2 times a. So 2 times a would be 2 times 2. So we have -4 divided by 4, which is -1. So our vertex is going to be at -1. And then we need to find the value of y. So y is going to equal 2 times -1 squared plus 4 times -1 minus 6. Okay, when we evaluate this, you got to remember that we always do exponents before we multiply. So it's not 2 times -1. It would be -1 squared. So we have to do this part first. So -1 squared. So -1 times -1 is +1. And then 2 times +1 would be 2. 4 times -1 would be -4. And then minus 6. So 2 minus 4 is -2. -2 minus 6 is -8. Okay, so our vertex is at -1, -8. All right, then to find the rate. So to find the rate of increase, I'm going to scroll down here. So we said that a is 2. So to find the rate of increase, the normal rate is 1357. Whatever a is, we multiply a by, or times, that normal rate of 1357. So if I multiply 2 times this, I get 2, 6, 10, 14, etc. Okay, so the rate for this problem, our rate of increase, is going to be 2, 6, 10. Okay, so from this point, from our vertex, so let's see, from our vertex right here, we're going to go up 2 over 1. Okay, and that matches up with our y-intercept. Up 2 over 1. Then we would go up 6. So 1, 2, 3, 4, 5, 6 over 1. then we would go up 10 over 1. And here's our graph. So again, the vertex is a minimum. The y-intercept, we already determined that, but the y-intercept is 0, -6. The domain, how far it goes left and right. The domain is always going to be all real numbers. And then the range, so the range is what's going to change. So this time we're starting down here at -8. And from -8, we're going up to positive infinity. Okay, let's try another one. So graph f of x equals 2x squared plus 8x plus 2. So this time a is 2, b is 8, and c is 2. So if c is 2, that's our y-intercept. So the y-intercept is going to be at 0, 2. Okay, and then let's start by finding the vertex. So to find the vertex, opposite of b divided by 2a. So b is a positive 8, so the opposite of that would be -8. And then 2 times a would be 2 times 2. So -8 divided by 4 is -2. Okay, so the x coordinate of our vertex is -2. And now we plug that in for y to find the, we plug -2 in for x to find the value of y. So we'd have 2 times -2 squared plus 8 times -2 plus 2. And again, when we evaluate this, exponents first. So -2 squared, so -2 times -2 would be positive 4. So we end up with 2 times 4. I'll just write this out here. Okay, so 2 times 4 is 8. 8 times -2 is -16. And then plus 2. So 8 minus 16 is -8. -8 plus 2 is -6. So our vertex is at -2, -6. Okay, so here's our vertex. And next thing we need to find is the rate. So to find the rate, we multiply a, which is 2, times 1, 3, 5, 7. So our rate, okay, so a, which is 2, times 1, 3, 5, 7, so on. So it'd be 2, 6, 10. So from the vertex, up 2 over 1. Up 1, 2, 3, 4, 5, 6 over 1. Okay, do the same thing on each side. Up 2 over 1. Up 6 over 1. Then if we were to keep going, it would then be up 10 and over 1. Okay, so now use these points to sketch your graph. So here is our parabola. Okay, answer the questions. Okay, again, the vertex is still a minimum here. The domain, all real numbers, and the range. So this time we're starting here at -6, and from -6 we're going up infinitely. So it would be -6 to positive infinity. Okay, so now this one, if you look, this time a is a -3. So because a is a -3, that tells us that instead of the graph going up, it's going to open down. And let's establish our values of a, b, and c. So a is -3, b is 12, c is 1. So since c is 1, remember this is the y-intercept. So the y-intercept is going to be 0, 1. And let's find x. So opposite of b divided by 2a. So b is 12, so opposite of that would be negative 12. And 2 times a would be 2 times negative 3. So we have negative 12 divided by negative 6, which is a positive 2. Okay, so our vertex, the x-coordinate is positive 2. And now we've got to plug that in to the original equation to find y. So we're going to have negative 3 times 2 squared plus 12 times 2 plus 1. Okay, and when we evaluate this, again, exponents first, so 2 squared is 4. So we have negative 3 times 4 plus 12 times 2 plus 1. So if we evaluate this, so negative 3 times 4, we're going to end up with negative 12 plus 24 plus 1. So negative 12 plus 24 would be 12. 12 plus 1 would be 13. Okay, so the vertex is at 213. I think that's going to go off our graph here, so he's got to extend it. So 213, so 11, we'll say 11, 12, 13. So here's 213. Okay, and then let's find the rate. So the rate, not enough room to write all this stuff. Okay, so the rate would be A, which is negative 3, times 1, 3, 5, 7. So negative 3 times 1 is negative 3. Negative 3 times 3 is negative 9. Negative 3 times 5 would be negative 15, okay, and so on. Okay, so from our vertex, we're going to go down 3. So down 1, 2, 3 over 1. Then from this point, we would now go down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. And what's kind of a nice check here is that hopefully as you're graphing this, that the points that you find, for example, this point right here, that should match up with our y-intercept. Okay, and it does, so that's just kind of reassures you that you're on the right track here. So here's our parabola. Okay, and let's answer our questions. So this time the vertex is a max, it's the highest point. The domain is still going to be all real numbers because the graph is going to go infinitely left and right. The range, so this time, okay, going from bottom to top, so the range is negative infinity, and it's going to go from negative infinity all the way up here to 13. 13's included, so it is a bracket. Okay, and there's our graph. Okay, let's try one more like that. So we have A is negative 3, B is 12, and C is negative 7. So find the vertex. So opposite of B divided by 2A. So opposite of B would be a negative 12. 2 times A would be 2 times negative 3. So we have negative 12 divided by negative 6, which is positive 2. So our x-coordinate of a vertex is 2. Plug that in to find y. So we have negative 3 times 2 squared plus 12 times 2 minus 7. So again, exponents first. So 2 squared is 4. So we have negative 3 times 4 plus 12 times 2 minus 7. So we have negative 12 plus 24 minus 7. So negative 12 plus 24 is 12. 12 minus 7 is 5. So our vertex is at positive 2, positive 5. 1, 2, 3, 4, 5. Okay, so here's our vertex. The rate, so the rate, multiply A by 1, 3, 5, 7. So we get negative 3, negative 9, negative 15, so on. So from our vertex, we're going to go down 3 over 1. Then we would go down 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. Okay, here's our graph. And let's double check here. So the y-intercept is at negative 7. So 1, 2, 3, 4, 5, 6, 7. Here's our y-intercept. That matches up what we have with our graph. So that's good. So 0, negative 7. Domain, all real numbers. The range, so it starts clear down at the bottom at negative infinity, and it's going to come all the way up here to positive 5. And then the vertex is a max. It's the highest point on the graph. Just looking ahead here. Okay, so let's just look at some of these. So this one right here, x squared minus 8x plus 21. Here's what we know just by looking at it. We know that it has a y-intercept of 0, 21. We know that it opens up because a is a positive 1. What else do we know? We know that the rate would be 1, 3, 5, 7. Okay, and so basically the only thing we'd have to do is find x by taking opposite of b divided by 2a. Then we would plug that into the equation to find y. Okay, then this is just kind of a summary of what we talked about today. Hopefully this lesson you can understand, kind of follow along with what we're doing. If you have any questions, make sure that you check with your teacher.